definition of the two stats I'm introducing. The first is percent TBA, which stands for percent of total bases advanced, which that's the technical definition for percent TBA. For this example, so we'll start with runners on the corners and a guy up to bat. In order to calculate the total possible bases advanced, you just count from each runner's starting position all the way to home. So in this case, from third to home it's 1, from first to home it's 3, and from batter to home it's 4. So in this scenario, the total possible bases advanced is 8. And that will end up being the denominator. So for the numerator, you have to count up what actually happened in the at-bat. So say in this situation, the batter hits a line drive to right center, which scores the runner from third, which is 1 base advanced. The runner from first moves up to third, which is 2 bases advanced. And the batter moves up to first, which is 1 base advanced, which means we had a total of 4 bases advanced, which gives us a 0.5% total bases advanced, or 50%, because we capitalized on 50% in that situation. If you change it up and you say that the runner or the batter gets thrown out trying to stretch the single into a double, he is credited with 0 bases advanced because he just cost his team an out, and so our percentage changes to 0.375% total bases advanced. So it goes down if you get thrown out, obviously. The next one is REC, which stands for runs earned created, which uses the runs earned 24 table, which in every base runner and out situation says you should expect to score this many runs. And that's the equation for it. So say we'll start with the same scenario and we'll give it 1 out in this situation because outs matter for REC. So our RE24 for pre-at-bat is 1.13 because of runners on the corners, 1 out. So say the same situation happens, a line drive to right center, guy at third scores, guy at first moves up to third, batter goes to first, which means that our state hasn't changed after the at-bat. We still have runners on the corners with 1 out, but a run scored. So therefore REC for that play is 1. In the change situation, so say the guy or the batter tries to turn the single into a double but gets thrown out. So therefore we end up having 2 outs and only a runner at third. So our RE24 in that situation is 0.353, which changes our runs earned created to 0.223, since he essentially just gained his team that run, but he also costed his team expected runs from the situation by getting thrown out trying to go to second. Okay, so here is the interface for IT statistics as well as some graphs and stuff that can pull up. So this uses data gained from my calculations.py that exports it to a .csv. And this just reads it in and allows you to kind of interact with it. So the first one will pull up the top, however many you want, percent total bases advanced seasons. And the current at-bat qualifier is 50 at-bats. So say I want the top 10. So that gives us that Kendrys Morales had the number 1 over only 56 at-bats in 2010, and his percent TBA was 289. So if we want to change the qualifier value, say we change it to 250 at-bats, go back. And so this gives us Mike Trout in 2012, had the highest with 288 at-bats and a percent TBA of 272. And it goes Joey Votto, Paul Goldschmidt, Jose Bautista, Miggy, Ellsbury, Josh Hamilton, Votto, Mike Napoli, and Miggy again. So say we can do the same thing with REC. And so this gives us Chris Davis, Miggy, Hunter Pence, Lance Berkman, who's not someone you necessarily expect to come out of that. The thing with REC is it's a bit more at-bat based. As you can see, all of the players there had high at-bats because you tend to accumulate REC throughout the season instead of it being as a percentage. You can also lose REC throughout the season if you just really suck at creating runs in general. But the more at-bats and the better you are, the higher your overall value or overall total is going to be. I mean, you can do it however many you want. You can do it with the top 30 players and it'll print all those out. And so then we can look at some of the graphs. So say we'll start with, this is just TBA versus at-bats. So this pulls up, it tends to kind of even out as you get into more at-bats. With only a few at-bats, it can be all over the place. and this just shows where the current qualifier line is, which I think is set to what, 250. And so as you get farther and farther out there, it tends to even out some, but obviously this is still a change from point, just below 0.3 to just a bit above 0.1. So that's kind of where you distinguish where the good players are at. So we can look at the next graph, which is going to be REC versus qualifying at bats. So this one, as you can see, it was pretty at bat dependent as it kind of spreads out as you go up though. So I mean, you end up getting players all the way up here who have the REC of 150 versus players with the same number of at bats who are all the way down at below 75, so half of that value. But it's hard to have a really good REC value without having a fair number of at bats. You can't really get up to 150 without having at least 500 at bats or so. So then if we look at TBA versus REC, so these are my two stats compared. It creates kind of a weird look to it. It kind of gets that really, really steep normal curve look behind it, but it's also kind of slanted right oddly. So I made the cutoff 0.6. There's a few outliers that are way out here that aren't very important, but it kind of creates that weird shape. Most people are grouped in here, but it's a very weird shaped grouping. So if we go up to 7, which is going to be box plots of TBA by year. So there's not a whole lot of change here. You can see that there's some of these outliers that are probably small at bat outliers, especially at 1. It's not really possible to have 1 over an entire season, but not a whole lot of bottom outliers. In 2010, 0 isn't an outlier, but it is every other year. But the general shape of the box plot is usually pretty similar. I guess it's a bit wider in 2010 than any other year. So now we can look at REC by year. And so this gives us, it's the same thing. The boxes in general look pretty similar. There's a bit of variance. Here you're talking 30, here you're talking 36 or something. But the median is always in the lower end of the box plots for these, or in the lower end of the box, followed by a bunch of outliers up high, with a really long distance between your Q3 and your outlier designation, because it's not really a max in this point. So that's my user interface for that.